know that President Obama's rating was a approval rating was 22%, and we're told about this presidential hopeful Randall Terry, who speaks at a short rally, and assumes that his approval rating as a candidate will likely closely mirror President Obama's. Suppose there are 40 swing voters, i.e., voters that are on the fence about who to vote for. What is the probability that all 40 voters will strongly approve of Terry's plan? So we've got to make the assumption that these individuals, since Randall Terry is going to assume that his approval rating would be just equally as high as President Obama's, so we're assuming a 22% approval rating. Now that's kind of a stretch because obviously this is a different person, and we're just assuming just because he's a Democrat, we're going to assume the same approval rating. So we've got these 40 swing voters, and we're also assuming that these 40 swing voters are going to behave similarly to the 22% of the nation's strongly agree factor. And the first thing we want to know is what is the probability that all 40 voters will strongly approve of Terry's plan? So the first thing we need to do is we need to say, okay, so the probability that 40 voters strongly agree. So the probability that one person will strongly agree is 22%. Okay, well, the probability that the second person will agree is 22%, and the third is 22%, and the fourth is 22%. So we're assuming independence, i.e. that these individuals' decisions are not affected by each other, and that people's opinions are independent. So that means 0.22 to the 40th power, which we will calculate 0.22 to the 40th power, and that is tremendously small. That's approximately 0%. So do we expect something that small? Well, if you think about the probability that one person strongly agrees in terms of this person's performance, that's very small to begin with. So now to get 39 other voters to also strongly agree, whose likelihood of agreeing individually is very small, the probability that they will all strongly agree should be tremendously small, which it is. What is the probability that none of the 40 voters will strongly approve of Terry's plan? Well, so let's just look at one person. The probability of not strongly agreeing, well, that's going to equal 1 minus the probability of strongly agreeing. Because again, probability, you either are here or you're not there. So you're in one of two places, and so the probability of not strongly agreeing and strongly agreeing has to add up to 1. So 1 minus that has to give me the remainder. Now keep in mind, just because you don't strongly agree doesn't mean you strongly disagree. That just means that you could agree, have no opinion, disagree, or strongly disagree. Okay, so for one person, well, we know that the probability that one person strongly agrees is 0.22. So it's kind of like maybe a little bit more obvious. The formula may complicate this a little bit more, but so if there's a 22% chance that you strongly agree, there's a 78% chance that you don't strongly agree. So now we want to know the probability that 40 don't strongly agree. So I'll just write this very primitively. 40 not strongly agree equals, similarly, 0.78, probability of one person not strongly agreeing, times the second person times the third, etc., which this gives us a probability that should be a little bit higher, not much. Notice that this is still very close to 0, so this is like, if we wanted to round it, this would be about, let's see, 4 zeros and then a 4/8, and as a percentage that would be 2 zeros and a 4/8, so 0.0048%. So that's pretty close to 0%, still not very likely. So these extremes usually aren't very likely. Part C, what is the probability that at least one voter will approve of Terry's plan? So I'm guessing this means strongly agree, so probability that at least one strongly agrees. Remember, that's equal to 1 minus the probability that none agree. So in other words, from the probability space, take away all the people who don't strongly agree, or take away the probability that all don't strongly agree, and that leaves you with 1, 2, 3, 4, 5, 6, 7, etc. strongly agreeing. So we know that the probability that none of the 40 strongly agree is 0.0048%. which is 0.000048 is a decimal, and that is 1 minus this answer right here, which is about 0.99995, or 99.995%. So very likely that at least one person will strongly agree. So he's pretty confident that he can get at least one person to strongly agree.